Hi everyone, today I will be using Malleable from Distorted to make some music. Let's get started. I've already created an oscillator that outputs a saw wave based on a MIDI input. You can see from the graph that there's a single block instance named chord, which is using the chord block definition. It has two inputs, one for the MIDI gate and one for the MIDI note, and I'm sending values to these from the first MIDI voice. There's an output for the audio, which I'm sending to the left and right speakers, as well as an oscilloscope. If you look at the code, you can see that the volume is being set using an attack, decay, sustain, release envelope. I'd like to begin by modifying the block definition so that it lives up to its name and outputs a chord instead of a single note. You can see that buff audio A is currently having its value set using this wave function. I'm going to add three more audio buffers, buff audio A1, 2 and 3, and I'm going to assign the output of the wave function to the first of these and then duplicate that for the second and the third. For the second, I'm going to increase the MIDI note number by 3 semitones for a minor third, and for buff audio A3, I'm going to increase it by 7 semitones for a fifth. I'm then going to add these together and divide by 3 and assign that value to buff audio A. Now, when I play a key, we should hear a minor chord. I'm going to make the sound more interesting by blending the saw waves with some square waves. To do this, I'm going to add another set of buffers called buff audio B that will work in the exact same way, except that they will use square waves instead of saw waves. I'm going to combine them together in the same way. And then, if I save my code, we should now still hear the saw waves. But if I change this to a B, we should now hear the square waves. I'm going to add another buffer called buff mix A, which I'm going to use to control the volume of buff audio A, and buff mix B for buff audio B. For now, I'll set buff mix A to be 1, and I'm always going to set buff mix B to be 1 minus buff mix A. I'll multiply this sum by buff mix A, and this one by buff mix B, and then I'll add buff audio A and B together here. Now we should hear our saw waves again, but if I change this to a 0, we should get our square waves. Changing it to 0.5 should give me a blend. Up here, I'm going to add a new input called input blend, and I'm going to use this to set the value of buff mix A. I'm going to send a value from UI12, which is an input user interface port, to chords input blend. And I'm going to define that down here to be a knob. I'll position it next to my oscilloscope. And I will give it a minimum value of 0, a maximum value of 1, and a default of 0.5. If I save my changes, we should now be able to use it to control the blend. I'm going to add another input called input detune. I'm going to give this a minimum value of 0.99 and a maximum value of 1.01, and I'm going to use this to detune my saw waves. I will multiply the output from these 3 MIDI to Hertz functions by input detune. Multiply, not add. And then I will send UI13's value to chord input detune. UI13 will be a knob, and I'll give it the appropriate minimum and maximum values and a default value of 1. Let's test it. If I turn this knob on my MIDI controller, you can see that it's sending a value for controller 74, and this one is sending a value for controller 71. I will modify my knobs to follow those. And I think that by detuning the saw waves, we get a nice thick sound. Now that that's working, I'd like to add another instance of chord so that I can have two voices. I'm going to begin by renaming chord to chord 1. And now I'm going to create a second instance of chord called chord 2 and duplicate these sends. Instead of voice 1, I'll use voice 2, and I'll use interface inputs 22 and 23, and I'll use output 21 for my oscilloscope. I will follow MIDI controllers 76 and 77. And I've positioned my knobs incorrectly. There we go. Let's try it. Okay, so it's working, but we can't hear it, and that's because we need to send the output from chord 2 somewhere. I'm going to send it to the first output on my board brain optics in my Eurorack, which I'm going to connect to this VCA. I'll send the output from chord 2 to audio output 9 in Malleable, which I have mapped to that first output, and now we should be able to hear it. I'd like voice number 2 to actually be more of a lead, and so to do that, I'm going to repurpose my chord block definition. I'm going to create an input called input solo, which by default will have a value of 0. But when there's a non-zero value sent to it, I'm going to override these steps with these ones. And these steps are simply going to ignore the second and third audio buffers. Let's send a value of 1 to chord 2's input solo and try it. Great. Let's also put a low pass filter on the solo. So I'm going to override this step with this one, if input solo, and I'm going to use a low pass filter. I'll create a cutoff input above, and we're going to have a bit of resonance on it. Let's create the input for the cutoff. We'll give it a minimum value of 100, a maximum value of 10 kilohertz, and a default value of 1 kilohertz. Let's try that. And now, to make it sound really good, let's use an LFO to change the cutoff. So I'm going to define a new block called LFO. I'm going to give it a single output called output, and I'm going to set the output using a sine wave at 1 Hertz. I want it to give me a value between 500 and 1000, so I'm going to divide that by 100% and multiply it by 500 to get a value between 0 and 500, and then I'll add 500 to it. I'll use my LFO block definition to create an instance named LFO, and I'm going to send LFO's output to chord 2's input cutoff. Oh, I wrote chord instead of chord 2. Let's increase the range a little bit. Let's go from 300 all the way up to 1500. Cool. I also want to change my release time a little bit for the lead. So when I set the volume, if input solo, let's just have a release time of 50 milliseconds. Great. That's all working fine. I would like my chords to pan from left to right. So again, I'm going to create a new block. We'll call it pan, and we'll give it an input for the audio, and 2 audio outputs, one for the left, one for the right, and we'll create some buffers so we can control the volumes of those. We'll set buff vol L using a sine wave at 1 Hz. We'll divide by 100% to get a value between 0 and 1, and we'll set R to be 1 minus L. We'll then set our output audio left by multiplying input audio by buff volume L, and we'll do the same for the right. Let's use our pan block definition to create an instance named pan and send the output from chord 1 to pan's input audio. We can then send pan's out audio left to the left speaker and pan's out audio right to the right speaker. Okay, so it's way too fast. Let's go for 0.2 Hz, and let's also use a triangle wave instead. Cool. And I'm going to send these outputs to some more oscilloscopes so that we can actually see the output from pan as well. So UI out 31 is going to be a scope. I'm not going to normalize it. I'm going to do it over half a second, so 500 milliseconds. And I'll position it underneath the others. Cool. So let's have a look at the graph so we can see what we've made so far. We can see there's our 2 chord block instances, chord 1 and chord 2, which is our lead. The cutoff for chord 2 is being set by the LFO block, and the output from chord 1 is going to the pan block with its output going to the left and right speakers as well as the oscilloscopes. Oops. Okay. So now let's use this block I've created up here. I created a block called sequencer, which is for a 16-step sequencer, and I'd like to use that to play the chords for me. So let's get started. Firstly, I'm going to instantiate an instance of that block called SEQ, and I'm going to send its single output, which is the step number, so that we can see it. So I'll use user interface output 41. It'll be a value. I'm just going to put it underneath everything else. So that should start running, and when that hits 16, it should go back down to 1. So while that's running, let's create our first channel on the sequencer, which is going to be control the rhythm of chord 1. So we're going to add a buffer called buff gate 1 and an out called out gate 1. And we're going to set buff gate 1 to pretty much always be 0. But when the clock is non-zero, I'm going to use a selection function, which will look at the step number, and it's going to pick one of 16 values. So I'm going to say that we have 4 bars, each of 4 beats. And for now, I'm just going to have it be high on the first beat of every bar. And then I'm going to set my out gate 1 using an attack decay envelope triggered by buff gate 1 with no attack and 50 milliseconds of decay. Let's send sequencer's out gate 1 to chord 1's input MIDI gate. And let's just send a value of 57, which is a MIDI A, to chord 1's input MIDI note. So if we save that, it's working. And these 2 sends have overridden these 2, so I'm just going to comment those out. And I'm going to set our chord 2 to now be triggered by voice number 1. Cool. Okay, let's also set the note using the sequencer. So I'm going to add another output called out note 1. And this is going to be really simple. So let's just set it for now using the MIDI to, the note to MIDI function. And we'll give it a value of C3. And that will send a C3 equivalent out on note number 1. So let's send sequence out note 1, and we should now get a C minor chord. Great. Let's speed up the tempo a little bit. Let's double it. And then for out note 1, let's use an F3 if the step number is greater than or equal to 9, and a G3 if it's greater than or equal to 13. So there's our F minor and our G minor. Cool. Let's make the pattern just a little bit more interesting, shall we? So let me just do that. Okay, and now that that's working, let's add some rhythm. To do that, I'm going to use my Eurorack again, and we're going to use this module here, which is a llama from Pittsburgh Modular. I'm going to trigger it using this output on my board brain Optex, and I'm going to send the llama's audio output to this mixer. Okay, now that that's connected and unmuted, let's create the outputs from the sequencer. So we're going to need a buff gate 2 and an out gate 2. It's going to work pretty much the same, except that our envelope is going to have different attack and decay times. So I find that an attack of 10 milliseconds and a decay of 10 milliseconds works for this module. And because this is a kick drum, I do want it just to go on the first beat of every measure. Let's send sequences out gate 2 to audio output 10, which is that second output on my board brain. Okay, let's have a listen. And now that that's working, I want some hats. I'm going to use this module here for both a closed and an open hat. I'm going to trigger the close from this output and the open from this one. These are going to work in exactly the same way. I'll create a buff gate 3 and 4 and an out gate 3 and 4. And I'm just going to do a really basic hi-hat. And of course, I'm going to make the open the inverse of the close. Let's send it out. And I think it would be cool to put those hi-hats through a bandpass filter, so I'm just going to reconnect it. And I'd like to control the cutoff for that filter using an LFO from Malleable. So let's connect that. Next output on my board brain, and let's create a new block. We'll call it bandpass LFO, and I'll give it an output called output. I'm going to set the output just to be a sine wave at 1 Hertz. In fact, yeah, that should work for now. We'll use BPLFO to create an instance called BPLFO, and I'll send its output to the next output on my board brain. Great. Okay. I think we should increase the tempo just a little bit. So let's go with, and actually, maybe we should lock the tempo of the bandpass filter in with the tempo of the sequencer. So I'm going to use the BPM to Hertz function. And so we're currently got a tempo of 240. I'm going to knock that up to 280. I'm going to set the frequency of the bandpass LFO using a tempo of 70. Nice. I'm going to slow it down though. I'm going to halve that to 35. Great. Cool. I'm liking that a lot more. I think we need a bass line. I think I should use this module here in my Eurorack. And of course I'm going to control the pitch and the level of that oscillator using Malleable. So we're going to set the level using the next output on my board brain, and then we're going to send a value to the 1 volt per octave input using the very next one. Okay, so firstly, I'm going to add a new gate, buff gate 5, and then out. We'll call it. It's not really a gate anymore, so we're going to call it out level 5. And then we're also going to have another output called out pitch 5, which will be the pitch for that oscillator. Let's set up the pitch first. So I'm going to set out pitch 5 for now to be 0%, which will be equivalent to 0 volts. And while I'm here, so out level 5, out pitch 5, so I'll send sequences out level 5 to audio output 14. I'm going to send out pitch 5 to audio output 15, except that it's going to be a calibrated audio output. And what that will mean is it will guarantee that a value of 0 will be 0 volts, 10% will be 1 volt, and 20% will be 2 volts, etc. So let's just now create our level. So we're going to buff gate 5 and out level 5. And out gate 5, we're going to set out level 5 using buff gate 5. And let's just give it a little bit of attack, a little bit of decay. And let's just set buff gate 5 on every note that the clock is high for now. There it is. I'm sorry, I didn't realize I was covering up what I was doing. Down here you can see that I sent out to audio output 14 and calibrated audio output 15. So instead of outputting on every note, let's do something a little bit more interesting, but instead of a selection, I'm going to use a Euclidean function. So if we say we have 16 steps and we're going to play on every step with no offset, it's going to sound exactly the same. So I can halve the number of steps, halve it again, and halve it again. Let me increase that release time there. And so now instead of 2 steps, which is not very inspiring, let's increase it. I'm going to go a little bit different and do 9 steps, and let's set an offset. I like that. Let's set the pitch. We've currently got it set to 0%. Let's change that. So we're going to use the note num function, which will take a note such as C0 and give us the equivalent value percentage-wise, which in this case happens to be 0%. So let's increase that to an F0 if the step number greater than or equal to 9, and we'll go with G if it's greater than or equal to 13. Let's go with a B flat minus 1. And let's also add an E flat for step 5. Okay, great, I'm happy with that. I'm going to add one more oscillator. So I'm going to add this one here. I'm just going to keep it on a constant note, but set the rhythm by sending a value from the last output of my board brain octaves. So again, let's do the same thing we've done for the first oscillator and use a Euclidean function to set the rhythm. So we'll have we'll call it an out gate 6, because it's technically going to be a gate, and we'll create a buff gate 6 for the rhythm. Now, let's set it to play every step. Let's just set the rhythm. Instead of 16 steps, let's go a little bit weird. Let's have 13 steps and we'll play on 9 of them, and I'll just have an offset of 1. Cool. Let's have a look at what we've built. So you can still see our chord blocks. There's our LFO, which we're using to set the cutoff. There's our pan block. Here's our sequencer, which is now sending a lot of values out to the Eurorack audio channels. And there's our BP LFO, which we're using for that one audio output. Pretty straightforward. Thank you for watching. If you'd like to know more about Malleable, please visit the Distorted website.